So even though this plot is looking okay, it's not perfect. As you can see, there's a lot of transparent blue and red dots down here in the bottom left corner of the figure, and it's a little bit difficult to see what's going on down there. It might actually be better to keep the microlith and Buran data separate. There are, again, a variety of ways to do this, but a simple one is to just create a multi-panel plot. Instead of having both sets of data plotted on the same plot, we can create two separate plots. Now, simply, you could just, let me delete these xlab and ylab arguments here, and I changed the plots function instead to the points function to a plot function. Now, running this would produce one plot of microliths, a second plot of Burans, and we don't need the legend function for this. However, with these two separate plots, you would need to export them separately, combine them in a different software program to get them into kind of one figure if you wanted them to be in one figure. One thing you can do within R to get both of these figures, both of these plots into just one figure that's a multi-panel figure, is use the parameter function here, PAR. In order to do this, we need to specify two different arguments, really. First, we need to say that we're going to create a multi-panel plot. And the way that we do this is by using this mfrow argument. This argument here controls how many rows and columns of plots we want. So if I were to run this right now, it would create 2 rows of plots and 1 column of plots. I could reverse this and say I just want 1 row of plots and 2 columns. This means that there would be 2 plots side by side, whereas 2 rows and 1 column mean that there would be 2 plots, one on top of the other. However, I need a second argument here. I need to change the margin sizes because it won't plot at the current margin sizes. And what I've just done here is say MAR equals concatenate 5522. The default margins around a plot in R are 5.1, 4.1, 4.1, and 2.1. That's just something that I've learned over the years of doing this. The way that these dimensions and plotting work, it starts on the bottom and then works clockwise. So the first value is referring to the space at the bottom of the plot. The next value is referring to the space to the left-hand side of the plot. The third value is the space at the top of the plot, and the fourth value is the space at the right of the plot. By changing these a little bit, and changing this mfrow argument, if I run this now, nothing happens, but now run the 2 plot functions we've got. I now get 2 different plots that are one on top of the other. As I said, I wanted 2 rows and 1 column of plots. This is 2 rows and 1 column of plots. We can see that we can see a little bit more clearly what's going on in the bottom left corner of these plots now that they're not superimposed on each other with the 2 different colors. It's just a little bit neater. However, as it is, looks pretty bad. We want to do a bit more manipulation of this figure before it's really ready for publication or for presentation. Now we can add our own labels, of course, and change things that way, but I would recommend not doing that yet. That can come later once we clean things up a little bit more. In fact, I would recommend even, for the time being, saying xlab equals empty quotes, nothing. And the same with the ylab. Doing this, I plot it again, removes the x and y axis labels. I want to do the same thing for the second plot function, so I just highlighted it and copied it down there. And now I've plot that, no more axis labels. We're going to add them back in later, but it's just a little bit cleaner for the time being and easier to manipulate these if we get rid of them right now. Let's also shrink down the margins, because you can see there's a lot of space between these plots. So let's shrink these margins down. This can require a bit of trial and error, playing around a bit with numbers that look better than others. So here I've shrunk it down to 4, 3, 1, 1. That's 4 space on the bottom, 3 on the left, 1 on the top, 1 on the right. Now we can see this plot's looking a little bit nicer. We've gotten rid of some of that extra space around the edges, and it's cleaning up nicely. Now what I want to do is actually turn off these axes. I think that having the boxes around these multi-panel plots makes it look a little bit less nice. So I want to use the axes function and set it equal to false. If I add that into the plot, you'll see that when I run it, it turns off the axes. There's now no box around the plot, and there's no tick marks on either the y or the x-axis. I do that again then for the second plot and run it, and there we have it. Now here's an interesting thing too, is that you can either type the full word false in all caps or just type a capital F, and R will interpret that as a false in a logical sense. So now that we've got this, it's kind of looking nice, but it's also still very empty. We actually want to add some axes back in, just not the full axes. So what we can do is use the axis function. The axis function you can see in the help file, or if I just leave it, if you just type the axis function and open the parentheses, it should bring up a little box that explains to you what's going on. The first argument in that is the side argument, which again is bottom, left, top, right in that order, 1, 2, 3, 4. If we want to make a y-axis kind of set of tick marks on that first plot, we would put a number 2, because a number 1 would be at the bottom, that's the x-axis, and number 2 would be at the left, which would be the y-axis. So now if we run this plot function, the red one, and that axis function, we now have a nice axis just ranging from the values that we've got for these data along the y-axis, and not plotting a full box around it, not plotting on the x-axis either. So let's do this for the next plot too. So when we plot that and then add this axis, there we have another nice one. Now there's no x-axis here, no labeled x-axis. So let's add one. If we use this axis function, but we put the number 1 in it, that's saying put an axis labeled at the bottom, and there we have that. This is looking a little bit nicer, I would say. We're starting to get there. Now, one thing is that I don't particularly care for how that x-axis is flush up against the blue dots on the bottom panel. So let's manipulate that a little bit. There's another argument in the axis function. Again, you can see all of these in the help file for the axis function. This argument is called line. If we specify line equals 0, that's what the default is. So let's move it a little bit. Let's say line equals 0.5. Now watch what happens. I've just shifted that axis slightly down. Again, it's plotting on top of itself. So let's run all of this again. But now this is looking a little bit nicer. There's more space there, a little bit more room to breathe, you know? And that's starting to look a little bit better, in my opinion. Now, what we can do next, now that we've got these axes nicely labeled, is start to actually, well, now that we've got the axes there, is to actually label them. So let's start off by labeling the y-axis on the top panel. And we can do this, again, whereas before we used the xlab function. You can still do it that way, but I also want to show you that there's another option called mtext. And this stands for margin text. This is a good thing that I like to use when I'm making these multi-panel plots, where you say, I want the mtext to say microliths. I want the side to be equal to 2. That's the left side, right? 1 is the bottom, 2 is the left. And the line, same as before, gives it a little bit of space. If I were to just plot this as is, the word would appear right on top of the y-axis that's currently there. So I want to give it a little bit of space. Let's try 2.5 and see what happens. So we run this. I've now got that y-axis labeled. It says microliths. But the margin is such that you can't actually read the word. So we need to change our margins a little bit more. As I said, this is a trial and error process. Now the first number is the bottom. Let's shrink it down a little bit just to see what happens. And let's shrink down, or no, we need to expand the second value because that's the left side, and we need more space to fit that word microlith. And now I've been able to fit it a little bit more nicely by changing the margin there on the left side. Now it appears. So let's plot then the blues, add that axis, and let's add an mtext function down here for Buran's. The side is also equal to 2 because it's on the left. The line will also be equal to 2.5. That seemed to work out before. And there we have it, a nice label there. On the bottom, we can do the same thing. We've got our axis there at the bottom. I can already tell we're going to run out of room. So before I even do it, let's change that bottom argument back to 4. Run all of this again. And let's see what we get. It's probably still not going to be quite enough. So the mtext here is going to be core and flake scrapers. The side is now equal to 1 because 1 refers to the bottom of the plot. And the line, we're going to need a little bit more space based on how thick that x-axis is. Let's try 3, just a little bit more. If I run that, there's core and flake scrapers. We could use a little bit more space on the bottom. Let's bump that margin up to 4.5 and run all of this again. And there we go. This is looking pretty nice. Yeah, I'm pretty happy with that. We're getting there. There are several other things that you can do. For example, right now there's actually quite a bit of space in the middle. You can see that the red panel is a lot higher up than the blue panel. And so what I want to do is, instead of using the MAR argument in this PAR function, I want to also use that, but I also want to use the OMA function. The OMA function, instead of the MAR argument, MAR stands for margin, OMA stands for outer margin. So let's set our inner margins just to 1 on all sides, just a little bit of space in every direction. And then the outer margin is what we're now going to use to control the space that we want to plot our axes and our labels with. So now if we run this and plot things again, I've been able to shrink that space, that gap in between the two panels, and still maintain the space around the edges. Again, this is trial and error. You'll need to play with values until you find something that you like. But I think this is looking pretty good. Now, you can add a bunch of other things to the plot, right? You could add grid lines, you could add a legend if you still wanted one. You could relabel the y-axis just as counts and put microliths and Buran's in a legend like we had previously. Change the colors, change the point styles, tons of different options. One thing that I will show you just quickly that you could do, let's add a line across each panel at the mean value so that we can show what the mean count of microliths and the mean count of Buran's is as a reference. And we can do that using the segments function. This is another common function for plotting that if you pull up the help page, you'll see how it works. But basically, you need to specify at the minimum an x and a y coordinate for where to plot this segment. And really, you need to specify the starting x and the starting y, and then the concluding x and concluding y, because this is going to plot a line segment. So let's plot from 0 on an x value of 0 and a y value of the mean of ESA sites BU. So what I'm telling it to do is say, all right, an x value of 0, so on the x-axis go to 0, and then on the y-axis go up to the mean of ESA sites $BU. That's going to be the starting coordinate for our line segment, and the concluding one, let's drag it out to a value of 32 on the x-axis, perhaps, and keep it at the mean value of ESA sites BU. Now let's change, if I were to plot this, you can see it plots a nice black line at the mean value of Buran's right across our plot. Again, running from this first pair of coordinates, 0 and the mean, to the second pair of coordinates, 32 and the mean. So it's producing a horizontal line because the y-coordinate is the mean in both cases. This segments function also has some other arguments we can manipulate, like the LTY argument. If I set LTY equals to 1, it's a solid line. If I set it equal to 2, it becomes a dotted line. I can also change the color to be gray, for example. Now, let's add a segment like this to our first panel as well. But we need to remember to change it from BU to M, because that's what we're plotting here, unless we wanted to plot the mean Buren value on top of the microlith plot, which you might have a reason for doing. Run the parameter again, plot the first one. There's the line segment, a dotted line at the mean value. Add our axis, plot the second panel with that dotted mean line segment, y-axis for the second panel, x-axis, and there you have it. That's a pretty nice looking multi-panel plot, in my opinion. This, again, is just a very cursory overview of some of the capabilities that you have when plotting with R, but this should show you that you can actually create really nice looking plots in just kind of using basic R functions. And so if you were to download a bunch of other packages, you can make these look even nicer.